Today's question: a police car with a siren of frequency 8 kHz is moving with a uniform velocity of 36 km per hour towards a tall building which reflects the sound waves. The speed of the sound in air is 320 meter per second. The frequency of the siren heard by the car driver is. So this question is based on the Doppler effect. But here in this case, the source as well as the observer are the same, because the source of the sound is the siren, which is given by the car, and the observer is the driver, which is itself sitting in the car. So here important part is that the source as well as observer is the same. So we are going to solve based on this question, based on this observation, that the source as well as observer is same. So we say using Doppler effect, but we have to keep in mind car is the source as well as the observer. So it means we can divide this question into two parts. Suppose this is the car and this is the tall building. And the car is, the sound will be traveling something like this, and this building is going to reflect the sound, and that sound will be heard by the driver. And the car is moving towards the building. So in this case, we could divide this question into two parts. First, we are going to assume that the building is the observer, which is stationary, and the car is moving towards the building. And in the second part, we are going to assume that the building is the source of the sound and driver is our observer, and once again that observer is moving towards the building. So based on this, it will be quite easy to find out the solve the question. So it means this question will be consisting of two stages. Okay, this will be our stage 1 and this will be our stage 2. So we start that first of all, let us write that we have a reflected sound. We have a reflected sound, and so which basically means that the sound from the car siren, the sound from the car siren reflects off the building and it return to the car. Return to the car. So like I said, it will be consisting of two stages. So we can say that is two stages. So let us solve for first stage. First stage, which we have written as stage 1, sound is received by the building. Sound is received by the building, or we can say stationary observer. Stationary observer. So we can write the formula as the frequency received by the reflected building will be equal to frequency of the source multiplied by the velocity of the sound multiplied by Vc and divided by V, where Vc is the velocity of the source, that is car. So here our Vc is the velocity of source, and source in this case is a car. Fs is the frequency of the source, and V is the velocity of sound in air. Velocity of sound in air, or in the medium which it is traveling. So we substitute the values which are given to us, so we can find out frequency that is reflected by the building will be given as 8000 multiplied by 320 multiplied by 10 and divided by 320. And sorry, it is plus. Let me check. Here also I've written this is plus, and here also it is plus. So we are going to get this as 8250 Hertz. Now this is the frequency of the sound that will be reflected by the building. Now we come to the stage 2. Stage 2, that is sound received by the moving car. Sound perceived by the moving car. So we can say observer is moving and it is moving toward the source. Now here source is the building. So you can say that observer, which is our moving car or driver, is traveling towards source, and source is our building, which is stationary, So it means we can write now the formula as frequency, that is our F, heard by the car, will be equal to frequency of the source, and that is our reflected building, multiply by the velocity of the sound plus Vc and divided by V. So we just substitute the values. We get this as 8250 multiply by 320 plus 10 and divided by our 320, and that will be coming as 8515 hertz, and we can convert that into kilohertz. That will be approximately equal to 8.5 kilohertz. So the option that is correct is our option number A is the correct option. Option A is correct. So this question was quite simple, but keeping in mind that the source as well as the observer are the same. This completes the question. Thank you.